Welcome to this tutorial regarding the control panel in TranAX. I opened TranAX already and I have to bring up the control panel. The control panel can be opened in the ribbon bar or with a small icon on the top of the software. Depending on your screen size, you have to adapt the size of your control panel. I've played around already with the hardware settings, so for bringing it back to the default value, I make a right click on the top of the control panel to bring back all parameters to the default. If some text in the header are cut, you can also reset the column length and then it shows you all the texts in full length. In the lower part of the control panel you have different tabs. Some of them change if you change the selection of your channel, and some are independent of the channel selection. We will start with the input amplifier configuration. First thing to select is if you want to make a single-ended or a differential measurement. If you select one channel, you can set the mode either to single-ended, differential or off. As I've installed only a single-ended board here, if I select differential, you will see that the channel A1 and A2 are combined to differential pair. So you have to connect your differential minus input to the channel 2 and the positive input to channel 1. Channels which are not used in the measurement should be turned off. The next step is to configure the input range. I like to show you the effect of different input range. I've connected a quite small signal to my input and I change now the input range from 10 volt to the smallest to 100 millivolt. As you can see, the signal is clipped on the top. If I choose a big range, like here 100 volt, the signal gets noisy as the signal is compared to the input range is too small. You can change the offset of the input range for having an asymmetrical input range. For that, change the offset value, for example, to 0 for having input range from 0 to 1 volt. Let's go to the physical scaling. If you are using a sensor or an attenuator, you can type here a factor or a sensitivity to get back your original value. So I type here 10 for having 10 times more signal. And if this would be a current probe, you can change also the unit to something else than volt. Just type your unit in this text field. You always see your input range scaled to your physical unit in this text field. So if you change the input range, for example, to something else, you see that your physical input range is also changing, corresponding to your sensitivity. On the right side of the input amplifier settings you find the filter section. These are hardware low-pass filter. Normally you have two frequencies available. If you have the anti-aliasing module installed, then you get much more filters. If you want to copy the settings from one channel to another channel, just type on your keyboard Ctrl+C and select the second channel and type Ctrl+V. It is also possible to select several channels on the same time and change the settings in the tab below. So let's have a look at the main settings. There are several different operation modes available. By default it is scope, multi-block and continuous. The ECR modes are an option and probably not available on your system. Let's have a look at the scope mode. In scope mode you can set the sampling rate and the block length. This together gives you the length of your measurement. Like on every oscilloscope, you have this auto trigger and single shot option. With auto trigger, the software will trigger the system if there is no hardware trigger available, and single shot means that there is only one measurement done and then the measurement is stopped. I've started the measurement now without auto trigger, and you see the system is armed but there is no recording. As soon as I turn on the auto trigger, the recording is running. If I zoom in, I see that there is new data coming. If I turn on the single shot, the measurement will stop. And if I start again, there is only one measurement done. The trigger delay defines the time before and after the trigger line. I can change to 0, so you have nothing before the trigger and everything after. Or you can bring it in the middle, as you prefer. Let's have a look to the multi-block mode. In multi-block mode you have one parameter in addition, and this is the number of blocks. I have done now a measurement with 3 blocks. You see the 3 trigger lines, and if you zoom in, there is a little gap between the blocks. If you want to see the blocks overlapped, you have to change the axis settings. For this, we change relative time with 0 at trigger, and all blocks are overlapped. You can switch back with right click on the x-axis and select relative time since start. The multi-block and the scope mode are so-called memory modes. That means that the measurement is done only in the memory of the data acquisition device. Therefore, the maximum memory is here limited to what you have installed on your board. In my case, it's 128 megasamples. If you choose the maximum, the number of blocks is limited to 1. If you have smaller blocks, the number of blocks is of course higher. Let's switch to the continuous mode. In the continuous mode, you can just select the sampling rate. If you start on recording, the data is streamed directly to the internal hard drive of the TranAX FE device. Keep in mind that the data throughput to the hard drive is limited. For the TranAX FE device, it is about 50 mega sample per second. So you have to calculate how many channels you have activated and multiply it by 2 and by the sampling rate. If your sampling rate is too high for the data throughput of the hard drive, there will be an error indication on the left bottom of your software showing that there is a data lost. It can be stopped in 3 ways. Either you press the stop button, or you limit the record size with the max record length setting in the control panel and activate the limit record size. For example, we make a measurement for 5 seconds and then it stops automatically. The third way is using the stop trigger. The trigger works like the trigger in scope or multi-block mode, and you can specify a trailer time, which is the time after the trigger until the measurement is stopped. I've switched to the trigger setting. First thing to do is to enable the trigger on your channel where you want to detect a trigger. The trigger can be activated on each channel or only on one channel. Next, you have to select the trigger type. The standard trigger are scope and window, and the other trigger here visible are part of the advanced trigger package. Let's have a look to the slope trigger setting. You can change the slope to positive or negative, or both of them. You can select the level and you have to specify a hysteresis. I test my trigger settings with 0.1 volt as trigger level. And now we see there is a higher peak in my signal, so I change my settings for catching this pulse to a higher trigger level. and now we catch this higher pulse. I've changed my input signal to show you the effect of the hysteresis setting. I've set the trigger level to 0 and also the hysteresis to 0 and set here to negative slope. I start a measurement, and actually, as you can see, if I zoom out, actually this is not only, as you can see here, this is not a negative slope. So what I have to change is here, I have to say, for example, my signal must be higher than, for example, this 0.05 volt, and then it must be the negative slope of 0 volt. I put here 0.05, start the measurement, and now as you can see, we always catch a negative slope. So the signal must depass here this 0.05 volt, and then we are looking for a negative slope. Last parameter here is the external trigger. All devices have an external TTL trigger. The signal is available on the rear side of the device on the 25-pole D-sub connector. The last thing we have a look at is the clustering. On the left side you have a setting for changing the view from normal to cluster. Selecting cluster will change the view in the channel list, so you'll see each board from each device separately. This is only a view setting. Now we can define so-called clusters. Clusters can be used to define different sampling rate, for example, for each board separately. For creating a new cluster, we right-click on the white field under the last channel and click on Add Cluster. Then we can add a board to the new cluster by just drag and drop it to the cluster number. Now we can change the operation mode and the sampling rate from each cluster separately. Let's make an example. We change the sampling rate from cluster 1 to a lower sampling rate, and as you can see, the single shot is always activated. It is not possible to use several clusters with the free running mode. We start a measurement and we compare now the sampling rate of these both traces, and as you can see, we have more sampling point on the green line, which is coming from cluster 0, than on the purple line. Let's change to continuous mode and we start a measurement with two different sampling rates. And if we compare the time resolution from these two traces, we see that we have two different sampling rates. For resetting the cluster settings, we can drag and drop the board B back to cluster 0, or click on the cluster and press on delete, and the cluster is deleted and two boards are back again in the same cluster.